Modern shipping. It's this massive, complex ballet, really. Goods moving all across the globe.
Hmm.
From a factory, maybe to a port, then a ship, off the ship onto a train, then a truck, maybe even a barge sometime.
Yeah, it's quite the chain.
It is. And every time you switch modes, ship to rail, rail to truck, you hit this potential bottleneck.
Exactly. That transition, the intermodal transport part, that's incredibly challenging. It often means, physically unloading cargo from one container
Loading
and
it.
reloading it into another.
Right. And that whole unload reload thing, it's not just slow. It uses up expensive space at busy junctions, needs extra labor, and crucially, it's where things can go wrong.
Oh, absolutely. Material gets lost or damaged or spilled during that handling.
It's a huge source of inefficiency. Waste, too, in the supply chain.
A really significant one.
So what if you could, bypass a lot of that? What if the containers themselves could somehow talk to each other, transfer material directly?
Well, that's the idea we're looking at today.
That's why today, we're diving deep into something called the Endo Dynamic patented interlocking container system.
Yeah, we've got sources here that really detail this innovation, its features, the design, and the potential impact it could have on logistics. It's quite interesting stuff.
So our mission in this deep dive is to unpack these sources for you, pull out the key insights, and really understand what makes the system potentially, revolutionary, and why it matters for anyone moving goods.
Okay.
Let's unpack this.
Okay, so the sources, they zero right in on that core problem in traditional intermodal transport. Like you said, switching modes, ship container to rail car, whatever, usually means emptying one container.
And filling the next one, double handling.
Exactly, double handling the material.
It adds time, labor, cost. And if you're dealing with bulk materials, powders, grains, chemicals.
That's where you get the spillage, the contamination risk, the actual product loss. It's a real headache.
And think about the space needed for all that. Room for trucks, trains, forklifts, maybe temporary storage areas. All at these crowded ports and rail yards where space is, super expensive.
Premium real estate, absolutely.
So this endodynamic system, it's presented as a direct answer. The sources describe it as modular stackable. But not just stackable like Lego bricks. It's designed specifically to make that transfer seamless.
Yes, that's the key takeaway from the sources. This system allows direct material flow between containers while they're stacked up vertically.
So you just skip that whole intermediate unload-reload step.
You eliminate it entirely, yeah.
Okay, that sounds like a pretty fundamental shift. How does it work? What are the building blocks here, according to the sources?
Well, first, they use these really robust modular frames. Made from steel or iron, maybe aluminum. They're designed to stack multiple units high, supporting the weight.
Right.
And they have integrated lifting lugs. That's important, means standard container handling gear can move them. No extra kit needed just to lift a stack.
Okay, so you stack these reinforced containers. But standard container, they're just big empty boxes, right? This system sounds like it has a different internal layout.
That's a crucial difference, yeah. Each container unit, it doesn't just have one big chamber. It actually has 3 separate internal chambers.
3 inside one container.
3. And each of those has its own inlet at the top and its own outlet at the bottom.
3 chambers. So wait, I could potentially ship 3 different kinds of material in one physical container. Or just use all 3 for more volume of one thing.
Exactly. That flexibility, handling mixed loads or just segmenting a larger volume, that's highlighted as a distinct advantage in the sources.
Okay.
Now, to make that direct transfer work when they're stacked, obviously those lower outlets need to connect really securely to the upper inlets of the container below.
And that's where this innovative sealing mechanism comes in, I'm guessing. Because just lining up holes isn't going to cut it with powders or liquids.
Precisely. The sources detail this system where sealing members actually extend down from the outlet of the upper chamber.
Ah, okay.
To create a secure and, importantly, impermeable connection with the inlet below it. They specifically say impermeable to air and water, vital for stopping spills and contamination, both during transfer and just sitting in storage.
So it's kind of like building a sealed pipeline right through the stack of container.
That's a really good way to picture it.
Yeah.
And these seals, the sources mention, they can be operated manually, think hand wheels, or they can be designed for full automation.
Automation. That's always a big deal in logistics now.
Yeah.
Okay, so the material flows down the stack through these sealed chambers. How do you get it out at the bottom, out of the whole stack and onto, say, a truck?
Right. The system integrates with a special conveyor unit that sits at the base of the stack.
Okay.
And the sources really emphasize its versatility.
Oh,
This base unit can use vacuum-negative pressure to suck material out,
okay.
or positive pressure blowing it out, or even just traditional mechanical conveyor belts.
So it can handle different kinds of
A
stuff.
very wide range of bulk cargo types, yeah. Makes it efficient.
And I noticed the sources mentioned an optional Venturi system. What's that about? Why would you need it?
Ah, the Venturi system. Good catch. It's an optional add-on, especially helpful for, let's say, tricky materials like fine powders or some granular stuff that doesn't flow easily.
How does it work, roughly?
Well, think of it like this. It uses the flow of air or fluid through a narrow constricted section to create a pressure drop. That pressure drop generates suction. It's kind of the principle behind an old car carburetor or some lab equipment.
Okay, so it creates suction right at the bottom outlet.
Basically, yes.
Yeah.
It helps actively pull the material out, gets rid of stubborn air pockets, make sure you get a really complete and efficient unloading, especially with materials that might otherwise bridge or clump up.
Right, okay. So we've got these modular, stackable containers, multiple chambers inside, integrated seals that are impermeable for direct transfer, and this versatile handling system at the base, maybe with that Venturi assist. What does all this mean? What are the big, impactful problems the system solves, according to the sources? What's the real so what here?
Well, the primary so what is a massive cut in those painful transfer delays we talked about,
Mm-hmm.
and the material loss that goes with them.
Right.
By letting material flow directly between stacked containers through those sealed connections, you just completely skip that step of unloading one to reload another. The sources say this dramatically cuts transfer time
Must do.
and practically eliminates the spillage and waste you often see in traditional bulk transfers.
Getting rid of that double handling step, yeah, that must save huge amounts of time at crowded ports or rail yards.
Absolutely.
Yeah.
And speaking of crowded hubs, remember that space problem?
Yeah.
Limited, expensive space?
Yeah.
The sources really highlight how the vertical stacking design maximizes storage density. You can store way more cargo in the same small footprint. They actually report the potential to triple storage density.
Triple. Wow.
And linked to that, reduce warehouse space costs by potentially up to 66%.
Hold on. Tripling density and cutting storage cost by 2/3 in those prime real estate spots. That alone sounds like a massive win for logistics firms, port operators.
It's a very compelling figure from the sources, yes. And beyond just space, it also boosts material handling efficiency quite a bit.
How so?
Well, the multi-chamber design gives you operational flexibility, maybe handling different materials in the same stack. And the fact that the base unit works with vacuum, pressure, and mechanical conveyors means you have one system that adapts to lots of different cargo types. No need for specialized gear for each transfer.
And those impermeable seals, what's the big impact there beyond just less mess?
Oh, it's crucial. For safety, environmental rules, and just product quality. Preventing spills and contamination means lower cleanup costs, fewer environmental risks, and making sure the cargo arrives uncontaminated.
Makes sense.
And the sources also mention features that support automation, things like automated operation of those seals and specific valve types. They mentioned nice gate valves, which are great for controlling bulk solid flow precisely.
Right, automation again. Reduces labor, maybe improves safety too.
Exactly. Less manual handling, lower cost, better safety records. That's the goal.
So how does this really stack up against, the standard way of doing bulk intermodal shipping right now? What's the key differentiator?
The absolute fundamental difference is that direct intercontainer material transfer, standard containers, you have to fully empty one before that material can go anywhere else.
Right.
The Endo Dynamic system basically creates a vertical flow path between the stack units themselves.
So the stack itself becomes part of the transfer machine in a way.
That's it, exactly.
Yeah.
It's also presented in the sources as highly versatile and scalable. It's a single modular system that can adapt to various bulk cargoes and transport modes, a more unified solution, instead of needing different procedures or temporary setups for every different transfer scenario.
And that multi-chamber thing gives flexibility you just don't get with a standard single box.
Right. Handling mixed goods or maybe different grades of the same product all within one physical container unit. That really streamlines the planning side of logistics.
Okay, now let's dig a bit deeper on something that adds a lot of hidden cost and, frankly, hassle. All the complex packaging and the sheer amount of extra tools or equipment often needed at every transfer point. How does the system address that?
Yeah, this is where the sort of self-contained nature of the system really shines, based on what the sources say. By having that direct material transfer between containers, using those integrated sealed connections, you just eliminate a lot of the middleman steps.
Meaning you don't need to dump stuff into temporary hoppers or repackage it into bags or different containers just to move it from a train to a truck.
Precisely that. The system streamlines the flow directly. And those integrated seals, they're apparently so effective at stopping spills that you often don't need secondary containment measures around the transfer area, things like drip pans or barriers, which are pretty common otherwise. And the multi-chamber design, plus the automation-ready gates and valves like those knife gates, or they mentioned pinch valves too, which are also good for sealing off bulk materials. It means you can control the material flow very precisely without needing someone with manual funnels or hoses or temporary connections between separate containers.
Okay, so less handling, less temporary storage, less repackaging. What about the actual equipment side? Fewer tools needed.
Well, remember those integrated lifting lugs on the frames?
Yeah.
That means standard container cranes and lifters can handle these units. You don't need special hooks or jigs just for this system. And the modular frame itself, it's designed to be stable when stacked. Doesn't need extra alignment bits or stacking hardware that some other systems might require.
It really sounds like a lot of the necessary functionality is just built into the container and its frame.
It is. The seals, the mechanisms to operate them, they're part of the container. The gates and valves controlling the flow, integrated. It's designed to connect to one standard type of base conveyor unit for unloading, not needing different unloaders for different situations.
Right.
That optional Venturi system. Also integrated, reducing reliance on external pumps or vacuum sources. Even basic safety stuff like ladders or non-slip plates for access can be integrated, meaning you might not need portable ladders or scaffolding just to check connections high up on a stack.
It really seems laser-focused on making the container unit itself do more of the work and interact directly with just minimal external gear.
That's the key insight from these sources, I think. They report that this integrated, self-contained approach transforms the whole packaging logistics into more of a continuous, closed-loop process. And they claim it cuts the overall handling steps by a reported 40 to 60%.
40 to 60% fewer steps. That's huge.
It's a big number. And because the design is standardized and meant to be durable, they also cite potential for 30% lower maintenance costs compared to traditional bulk handling containers and equipment.
And that Venturi system getting almost everything out.
Yes, that's a significant detail for valuable products. By effectively clearing out the material, it reportedly reduces product loss to less than 1%, which is a big improvement over many traditional methods where more residue gets left behind.
Okay, so to kind of wrap up this deep dive, the Endo Dynamic interlocking container system, based on these sources, really does look like a potentially significant leap forward for intermodal logistics.
It seems to be, yes.
It directly tackles those core headaches of transferring bulk goods. The delays, the waste, the space constraints, the reliance on all that extra equipment and handling steps.
It streamlines the whole thing by making the containers themselves smarter, more integrated.
Yeah. So if this kind of integrated direct transfer approach can, potentially revolutionize container shipping for bulk materials, it makes you wonder, doesn't it?
Where are you going with this?
Well, what other parts of the supply chain? Maybe internal factory handling, moving ingredients around, or even just how raw materials are received at a plant. Could they benefit from applying similar ideas, self-contained, interlocking systems that let materials flow directly without all the intermediate steps?
That's a really interesting thought, applying that principle elsewhere.
Yeah. It raises an important question for the future of logistics, I think.